Wanted to go ahead and get the solution to worksheet 4 so that you have that available. And we want to give a written description of the motion. So here we go. The particle starts at a backwards velocity of -5 meters per second. A backwards constant velocity from -5 meters per second for 2 seconds. At 2 seconds, it slows down going backwards until it stops at 7 seconds and stays stopped. That's it. So now we want to get the displacement from 2 to 4 seconds. So I'm going to show you one method that works like this. What I'm going to do is I'm going to actually go ahead and calculate the area, because it turns out that the area underneath the graph gives you the displacement. So that means I'm going to have actually a triangle and a rectangle together. So I have a rectangle plus a triangle's area. And so that's going to be 2 times this depth here, which is -3, plus 1/2 times the base, which is 2, times this height, which is from -3 to -5. So that's a height of -2. And so I get a total displacement of -8 meters. That's one way to get the displacement, but it's not what I call the recommended way. Instead, we're going to do the displacement after doing part 3. We're going to go ahead and get the velocity. We're going to get the acceleration at 3 seconds. The way we get the acceleration is we're going to do the rise over the run. So we're going to do, we'll actually use these points here. So this one is at 4, -3, and this one is at 2, -5. And we'll go ahead and get the slope in a second. And so we will actually go ahead and do the numbers here. So we have -3 minus -5. That's right. Over 4 minus 2. And so this gives me 2 over 2, which is an acceleration of 1 meters per second squared. Excellent. Now what we're going to do is we're going to go ahead and we're going to use method 2 to get the displacement. So we have v squared equals v naught squared plus 2 times a times x minus x naught. I just happen to choose that formula because it's got the displacement right here. And I'll go ahead and plug in numbers that I can. So my final velocity is going to be -3 squared. My initial velocity, -5, and I square that, plus 2 times 1, which I got from here, times x minus x naught. When I simplify this, I'm going to end up getting -16 over 2 as my displacement. And so I end up getting -8 meters as my displacement. So that's the solution to worksheet number 4. Again, we're not going to be doing motion maps on this exam, so I hope that's helpful.